Okay, this is the second installment for Math 31 Notes, section 13.2. And we're going to start out here by taking a little side trail. We're going to look at lines that are either horizontal or vertical. And their equations actually look quite different. Starting with horizontal lines. Lines that are parallel to the x-axis. They're horizontal lines. Their equations are always y equals some value n, so you can see three examples here, y equals 6, y equals -2, and y equals 0. These end up giving lines that are horizontal. Now you may notice that there's just a y variable and there's no x variable in the formula. So this one here says y has to equal 6. Since it tells us absolutely nothing about the x, you let the x be whatever you want. I've chosen here -2, 0, and 8, but the y has to be 6. So if you, for instance, look at that last point there, 8, -6, and somebody asks you, is the y value 6? You'd have to say yes. But what about the 8? Well, it doesn't matter. The y value has to be 6. Now, if you plot these points, you'll see a pattern here. 8, 6 would be right there. 0, 6 would be over here, and -2, 6 would be here, and you can see pretty quickly that we're drawing a horizontal line. And so I'm going to go ahead and draw that line. And I will label that line. First of all, indicate that it goes forever, but I'm going to label that y equals 6. That's the equation of that line that's horizontal and parallel to the x-axis at a height of 6. Okay, this next one here tells us that we have to use -2 for the y value. So here we go. -2, -2, and -2. There you go. So we go -1, -2. The next point is 3, -2. And then 7, -2. And sure enough, we're getting another horizontal line. This time one is 2 down from the origin. So when it's positive, you move the line upwards. And this one is negative, so you're moving it downwards. Now, if it says y equals 0 here, then you're going to use 0 for the y, and any numbers you want for the x. It doesn't give us anything about x, so let's go -5, 6, and 2. All right, -5 zeros right there, 6 zeros over here, and 2 zeros right there. And you can see that we're just retracing the x-axis. And the equation of the x-axis is y equals 0. So there's 3 examples of horizontal lines, and I'm going to make up another one here. But this time I'm just going to draw a line and I'm going to reposition it a number of times. I'm going to start up here, and this line right here would be y equals 10, y equals 9, y equals 4, y equals -7, and if I come all the way down here, y equals -11. Okay, so that takes care of the horizontal lines, and they're all y equals. Let me label that last one, y equals -11. Now, you'll notice that they all run parallel to the x-axis, so it's a little bit of irony here. All of the lines are y equals, but they are parallel to the x-axis. So if you can remember it that way, they're parallel to the axis that has the opposite letter on it. Okay, now vertical lines work in a similar way. This time we're constrained by a formula that says x is some fixed value. So for instance, that might be x equals -7, or x equals 8, or x equals 0. In all of these cases, we have just the variable x, and there's no constraints on the y whatsoever. So you can think of the y as being arbitrary. So I'm going to put -7 for x each time here. And then I'll plot this -7, -6 to get going. -7, -6 would be right there. And then -7, 4 would be the next point, which would be 7 back and 4 up. And -7, -1, and the pattern becomes obvious pretty quickly. We're dealing with a vertical line here. And I'll highlight the ends here. That's the line x equals -7. You'll notice that it parallels the y-axis. So vertical lines always have x equals formulas, even though the vertical axis has a y. Okay, on the next one here, we got some choices for y's, but the formula doesn't tell us anything at all about y, so those are just pick your own. 8, 8, and 8 is what we have to use for the x. So we'll start with 8, 0, and then 8, -3, and finally 8, 10. And once again, we get a vertical line. So it doesn't take long, and you realize that all vertical lines have this format, x equals. In this case, x equals 8. Since 8 in the x direction means 8 to the right, you can think of this as being a line that shifts over 8 to the right. Okay, finally x equals 0 is the next one. So we're constrained by putting zeros in for x's, but the points can have any y value whatsoever. So I'm going to say -4, 1, and 7. So let's see where that takes us. 0, -4, 0, 1, and 0, 7. And you can see that we're plotting points on the y-axis itself. So the y-axis has a formula of x equals 0. So that's the formula for the y-axis, x equals 0. Now, I'll make up another line here, and I'll show you some other possibilities. So let me just start off to the side with a vertical line, and I'll put several positions here. This would be x equals -2, and over here is x equals +2. And if I shift 1 over, that would be x equals 3. Let me see if I can plop it down in the right spot. Yep, that's x equals 3. That whole line has a formula of x equals 3. Okay, so that's horizontal and vertical lines. The horizontal lines are formulas that are y equals, and the vertical lines always start with x equals. Okay, we'll finish this note set with an application problem. And this is from the textbook. It's exercise 33 on page 989. It says the number of students measured in thousands taking the SAT college entrance exams from the year 2011 through 2015 can be approximated with this linear equation here. So that's the equation we're going to be using. And we're going to be graphing this data and using it to help us answer some questions down below. Okay, so what we're going to do to graph it is we're going to pick some representative years. And incidentally, the start here is 2011, but it's labeled 0 there. So when you get to the first number here, it's actually 2012, 2013, and so forth. So let's see, 2011 plus 5 would be 2016 right there. And 10 years later would be 2021. All right, so let's plug in some of these numbers. We're going to plug in, well, I think I plug in 0, maybe 5, and 10. Let's see what I did here. I'm trying to remember. Okay, there we go. Yeah, I did 0 for x, 5 for x, and 10 for x, and you can see the results on the side over there. Let's plot those results. When x is 0, the y is 1647. When x is 5, the y is 1702. And when x is 10, we get 1757. So we've got some approximate places there. And we're going to go ahead and connect those to get our linear equation graphed. And since this ostensibly will continue to grow, we'll put an arrowhead on that. Okay, now I think we've got some questions to answer down below here. They want to know if the point 71724 is on the line. So let's see. It's a little hard to tell from the graph, but that may actually be true. 71724. We are between 1700 and 1750. They're more or less in the middle, so that's a reasonable answer. But the only way to tell that is to actually do all the calculations. So what we're going to do is plug the 7 in, and you can see I did that right here, 7. And you get a true statement when you do that. So that tells us that, yeah, that is a point on the graph. Now we're supposed to interpret that and decide what it means. So I've written that off to the side here. The first thing is the 7. That would be 7 years after 2011. In other words, this is a prediction for 2018. So you write down all that you can put into this sentence here is, if the trend that data showed from 2011 through 2015 were to continue, I think I misspelled continue there, put a U there, and until 2018, sheesh, wrote that quickly, there would be 1,724,000 students taking the SAT. This 1724 is on this y-axis, and you'll notice up there that it says this is in thousands. So I had to include the extra zeros on the end of that number to get the right value. Okay, the last thing here is when would the graph predict there would be 1.7 million students? Okay, so let's see what that would be. 1.7 million would be 1,700,000. So since the chart is in thousands, we're looking for the number 1,700. And if you follow that across here, you find out that that happens right at that 5-year break, or really close to it. So 5 years after 2011, approximately 2016. And of course, you could go and since these notes are being made after 2016, you could go see how well that prediction was, and you could also check out this 2018 to find out if the trend actually did continue, because now we'd have solid data for those dates also. Okay, so this ends the notes for section 3.2. And it also ends the homework that you'll have to be doing for this semester, since after this section I will not be assigning homework. I'm sure that makes you happy.